Yeah, so this is Entity Framework Core Unchained. My name's Dan Mallott. I'll be your speaker for the next hour. So what are we going to talk about? First up, we're going to talk about configuration. So this is the behavior of Entity Framework Core that you can control either all the time or per statement. There are a number of really nice defaults, and there are some defaults that are not so good. We'll talk about access patterns. Not all your Crud is going to be created equally here. Foot guns, my favorite subject. My second favorite subject, and something I work into every talk that I give if I can, database design and how you screwed it up 20 years ago. I mean, how you can only do it right once. And then things that Entity Framework Core just isn't good at and that we shouldn't try to use it with. I have a great story about how I didn't take my own advice there, so we'll get there when it comes. And lastly, there should be some time for questions at the end. Right, who am I, aside from clearly an American? Right, as I mentioned, my name is Dan Mallott, Twitter, GitHub, LinkedIn. I am a senior principal for West Monroe. We are a business and technology consulting firm based primarily in the United States, but recently decided that going outside the United States would be good as well. So we have offices in Costa Rica and London. If you're interested in what we do or doing what we do with us, come talk to me afterwards. I've been developing software since 2011. I had more hair then. I did start out my life as a DBA before I became a developer. And actually, I did still have hair when I switched over, so I've lost all my hair as a developer, not as a DBA. Primary experience with Microsoft technologies, .NET, SQL Server, Cosmos DB, Azure, apologies. And I am in my spare time, an ice hockey referee. The ice is in parentheses because depending on where you go, people either see hockey and think it's that thing you play on a field with wooden sticks and balls, or what I know it as, which is we play on ice with skates and carrying deadly weapons. So that's what I do in my spare time. The fine folks in Illinois, so I'm based out of Chicago in the United States. The fine folks in Illinois seem to think I do a pretty good job with it, so I get to do interesting games. Again, if you're interested, come talk to me. Unlike when I spoke in Sydney a couple of years ago, there are actually ice rinks in Melbourne. So that's kind of cool. How many people in here are developers? Yeah. Anybody also a DBA or a DBA instead? No, okay. How many people work with .NET as your primary weapon of choice? Yeah, okay, so this next slide is going to be kind of redundant, but I'll talk through it quickly anyway. So we're talking about Entity Framework Core. So what is that? Two things. One, it's an object relational mapper. So in that role, it takes the results of a query, maps them into objects that you can then access in your code. The true power for Entity Framework and the reason why it's so widely adopted is the second piece of what's up on the screen, which is that it is also a very powerful query generator. So it can generate primarily data manipulation language, so the actual queries that get executed. If you use code first, which I will talk about later, it can also generate the data definition language for your database. Right. So let's talk about configuration. So, how many people are familiar with Microsoft documentation? Okay, you're all .NET devs, right? docs.microsoft.com? Yeah, okay. Right, so how many people are familiar with how great Microsoft documentation is at giving you the bare minimum? Yeah, right, so if you do this, which is the bare minimum, not quite the bare minimum because I actually, put my well, this just isn't going to work for me today. That's fun. Because I actually put my connection string in a configuration. All right, so this is, if you go to docs.microsoft.com, look up Entity Framework Core, say, how do I add this to an application? This is what you get. And this works really well, right? It works. We pointed at a database. In theory, we have a context defined somewhere. Maybe you generated it. Maybe you wrote it yourself. Hopefully you generated it. But there are some things that this does and doesn't do for us that we ought to be aware of. Please come in, sit down. So the first thing is query retry is not enabled. So if your query for some reason fails, how many of you develop with your database living in the cloud? Okay. Another data center, not in your building? Yeah. Maybe like it's on another continent, potentially, as well, right? Yeah, okay. Stuff happens. So by default, no query retry is enabled, which means if try number 1 fails, you get a giant exception. Number 2, all of your queries are tracked. I will talk more about what that means, but there is overhead associated with that. Third, any related entities that you want to access, you have to explicitly load. Again, I'll talk a little bit more about this, but that essentially means using that include keyword in LINQ so that we get the results of the related table back with our main entity. And then lastly, we don't really get a lot of logging. We get, our favorite one, which is instance of an object, or object not set to instance of an object. That tracks closer with that third one there. But really, we don't get a whole lot else. Right. Now, this isn't all bad. In fact, there's one thing here that we almost always want to keep. So a couple of things. One, we want to implement a retry policy. So many of the database providers, including, since you all are .NET folks and presumably work with some sort of version of SQL Server, the SQL Server provider allow us to define our own retry policy. And we should do that. We should use the proper tracking behavior. Excuse me. We will get more into that. In our development environment, we should make sure we're logging errors and warnings and potentially some additional good information, which I'll talk about here in a second. And then lastly, and thankfully with EF Core 6, apologies, this one's really hard to do, we should not enable lazy or eager loading proxies. Lazy and eager loading, does that resonate with everyone? Should I? Yes, okay. Should I explain what those are? Yeah, so just sort of in brief, eager loading, you're going to end up loading every related entity for your entity, which means that if you have a nice, properly normalized database, you're going to end up loading the whole bloody thing. And lazy loading is you're going to have far more queries than you actually need to get your, one person with 4 addresses. So, suggested configuration. And I have a bigger version. So, for everybody who is trying to take a picture of the small one, have a bigger one. Right. So this is the configuration that I generally start with. It's a good place to start. And let's kind of talk through from the top. So first of all, enable retry on failure. This is particularly important because I tend to use a lot of serverless versions of Azure SQL Database. What's the great thing about the serverless version of Azure SQL Database? It goes to sleep and saves you money. But then it goes to sleep, and you have to wake it up. And if you don't wake it up, your query fails. Right, so for me, I just do retry count 4, time span from seconds 1, so 1 second between each. You can define this in sort of any way that you like. So if you have a situation where you need to do some sort of like staggered back off with a Fibonacci sequence, something like that, you can configure it that way. Generally, just like wait a second and try it again is going to work. Lastly, on the far right there for you folks, the error numbers to add. So the provider handles a certain number, like certain ones by default. So if it's a deadlock, if it's a timeout, query timeout, an 18456, you didn't give the right password, kind of things. But then you can add some other error numbers, and those correspond with, for the SQL Server provider, the SQL Server errors that you would be reading. Right. Query tracking behavior, I like to use no tracking by default. Again, we're going to talk much more about that in a bit, in like 4 slides, 5 slides. And then in the development environment, we're going to log additional things. So first, and let me repeat, in the development environment, don't do this in prod, don't do this in prod, don't do this in prod. I said it 3 times. Don't do this in prod. Detailed errors. So we get field level error details, right? So instead of your query just going, well, that didn't work, when you tried to stuff 20 characters into a 15-character field, you'll get, hey, you tried to stuff 20 characters into this 15-character field. Useful. Secondly, sensitive data logging. So this logs all of the parameters that are passed from Entity Framework to SQL Server. Don't do this in production. In fact, don't do this anywhere that you're shipping the logs like off your computer maybe, because sensitive things get logged in there. So like I'm an American, so Social Security numbers are kind of an important thing. They govern our entire lives because, you know, people in 1935 got that right. Right, so sensitive data logging would log that into my log console. You probably don't want to ship that up to Azure. You know, I assume there's something similar here in Australia. Yeah. Or if you're dealing with any sort of GDPR thing, yeah, that's a thing too. And then I can configure some additional warnings to be popped into my log. And in fact, you can do this in production too. But these are more for my purposes and my developers' purposes. So there are two types of events that can be logged. What we see here are 2 core events. And these are sort of general non-provider specific things, mistakes that you might have made. So the first one, first without order by and filter warning. I'm not going to address the first versus single kind of holy war. You guys can make that decision for yourself. But if you're using either of them, you ought to be order by. You ought to be using order by, right? Because the order of queries out of relational databases is generally non-deterministic. Likewise, with the second one, row limiting operation without order by warning. Yeah, same idea. Row order isn't deterministic in the results that are returned. And so if we're paging data, for example, we want to make sure that we get different pages of 100 records. We don't want to end up with the same or a cross-section, or weird stuff can happen. There are also what are called relational event IDs, which are kind of informational about how Entity Framework is handling your model. They're interesting. I don't ever use them myself. But if you want to see like, hey, it is using an index or things like that, that can be useful. Any questions so far?
I think I've noticed some of those warnings come up by default. What are the defaults around that kind of log warnings?
remember. There are some that come up by default. In fact, some of these things have changed from 5 to 6. So that first one might now be a default. I think you'll get some like parameter mismatch warnings by default as well, like if you shove in an integer and it should be a string, that sort of thing. Yeah. All right.
Would you want to also do like a if define big file, because what happened to us is something is configured, what is the actual environment, and if the part basically removed the entire code that you have there is development, so even if something is meshed in, you wouldn't be able to see sensitive data at all.
Sure, yeah, so the question is, wouldn't you want to maybe not rely on your environment variable? Yeah, so this is how it works in our environments generally, but for you, make sure that you're doing this in a way that makes sense for you, so whether that's using the compiler directives or the environment variables or whatever it is, yeah. Commenting the code out. I mean, look, this is reality. That happens. It's fine. All right. Let's talk about Crud, because this is where we're really going to find ourselves either gaining or losing performance or having options to tweak how Entity Framework is getting data. This is how it gets the data. So we're going to go in order. So we'll start inserting some records. Right, so top screenshot. I inserted one record and I got an insert statement. This is expected. The second one, I inserted 3 records and I got a, oh, this really just isn't gonna work for me. That's unfortunate. I got a merge statement, which is weird. You would think that it would just be an insert statement with 3 rows instead of, right? So the question is, how did this happen, right? So the top 2 lines are what generated that insert statement. So I have 3 users in my collection. I add them, I save changes, and I got this, which is a merge statement. And this is different. How many people used Entity Framework in the .NET Framework days? Yeah, this wasn't how it did it. Right? You got just single insert statements, and it was awful. So here's the deal. Right, now it's a merge statement that was added in, or the behavior was changed in Entity Framework Core 1.1. So single insert statements are slow. True-ish. As with everything database, it depends. Inserting records is more efficient. That's almost always true. So if we're going to insert multiple records, let's use a merge statement to protect ourselves from some strange SQL generation issues. And the reason for this is sort of esoteric in that because we're using a merge, it essentially is generating T-SQL that is more guaranteed to work even if you have some strange values that you're putting in. So it's not necessarily a bad choice. And in fact, this is reasonably performant up to around 500 records. And it is definitely more efficient than running single insert statements. That being said, in your environment, you may wish to change this behavior. And so if you wish to change this behavior, we have what's called the max batch size. And if we set that to 1, then we'll get a single insert statement no matter what. There's a downside, which I'll talk about in a bit. But just be aware that the breakpoint is 3 records. So 1 or 2 records, you're going to get single inserts no matter what. 3 or more records, you're going to get a merge. It's reasonably performant, but if you need to change it, this is the way. Okay. I promised we were going to talk about query tracking. Right, so Entity Framework Core, and like Entity Framework before it, holds a lot of information about the state of the entities that it has retrieved. And it does this in order to allow you to pull an entity, make changes, and save it without having to do any of that state management or change tracking yourself, which is great. It's hugely powerful, hugely convenient, cuts down on the amount of code that you have to write. And in theory, the smart folks at Microsoft have gotten it right, more right than we would have. But there's a cost there, and that cost is overhead. Overhead in query execution, overhead in memory in your application. Question: if you are simply getting data from a database and returning it through an API, do you need to track that data? Okay, good. I'm seeing heads go this way, which is good. Yeah, probably not. So if you are going to simply return the data that you're getting, or you're not making any modifications to it that would need to be saved back to the database, or you're using not the objects itself, because I'm sure we've all run into this one, but the data within the objects to hydrate a different object, yeah. Choosing no tracking is going to save you about 30% overhead. And so that's query execution time and memory. It is actually like significantly faster. This one weird trick. Likewise, on the other side of this, if you're modifying the original entities, or you need to like pull an entity and attach it to another one, or you're doing some delete operation or something like that, as tracking. Now, the reason that I present it this way with the function is, so if you remember back when we were talking about our configuration, I said the default query tracking behavior was no tracking. So by default, we track everything. In my configuration, I said don't track anything. But on any of your LINQ statements, you can add one of these, and it will do that thing. So if you've decided, yes, I'm going to track everything, but I don't need this one tracked as no tracking. If you said, don't track anything, but you need this one tracked as tracking, right? So this can be a decision made at the query level in addition to at the configuration level.
Yeah, and I've also done some testing with no tracking, and it also gives you up to 50% less memory usage. So it's not only faster, it's better for memory as well.
Yeah, so that's so gentleman in the back said he's found that it was up to 50% less memory. I say 30% on purpose because that's when the memory usage is really dependent on the situation that you're using it. So I like being conservative. I'm a consultant. I don't want to overpromise and underdeliver.
If you have tracker 10 on by default, but you use projections to select your entities into DTOs, does that disable tracking? I'm not sure.
Hold that thought. Short answer, yes, but hold that thought. All right. Yeah, so I use a lot of no tracking because a lot of what I build are just APIs. So makes sense. All right. Unfortunately, for everyone in this room, updates and deletes you don't really have any control over, except you'll notice a substantial difference between the top one and the bottom one. So the top one, we're doing an update. The bottom one, we're doing a delete. On the top one, I had not set what my max batch size should be. On the bottom one, I had. So this is the drawback that I mentioned with max batch size. So I set max batch size to 1, and I got a single connection with every statement, which was a sort of unhappy discovery. Because this is definitely less efficient. So just be aware of that. You're going to get a single update or delete statement no matter what you do, but it's way better to have that top one where at least they're only issued in one command instead of like 4. Is it 4? Yeah, 4 different open connections to your database, which are issued sequentially, not at the same time. So you don't even get like more benefit from doing things async. Okay, how are we doing? Half an hour. All right, foot guns. Easy ways to shoot yourself in the foot. Okay, so we already saw some bulk manipulation of data, right? This is something that any framework's really kind of never been good at. The situation improved in core, but didn't get substantially better. Lazy loading entities, tracking for read-only scenarios, retry policy. Let's talk about some other ways we can kill our performance. So my friend's point with projections. Yeah, using the auto-generated entities. So because we all like shortcuts, right? That's why we're developers. So we're lazy in like a not bad way, right? So DB context scaffold, and then you get something that nicely matches your database and pulls back way more data than you need, right? So we're going to talk about using projections. Loading too many related tables or too few. Too few, you get a nice exception. Everybody loves that one. Too many, you're just pulling back too much data. Too much data, more memory, more query execution time, right? What's the fastest query you can run? It's not a trick question. No query at all. Yeah. Everyone in here is fortunate to be using a version of .NET Framework or .NET Core that has async. Async await, yeah. Okay. It's a legitimate question. I worked on a product for 2 years that we had to compile to .NET Framework 3.5 because we had to be able to run it on Windows 7 machines that weren't patched. That's all I'll say about that. But yeah, so async query methods are going to give you better performance, generally. And then lastly, and we'll talk much more about this, defeating the indexes on the database by not understanding how they're used. Okay, so let's start with our projection. We're using select. So, Stack Overflow database, we're all familiar with Stack Overflow, right? So as you can imagine, the post object has a lot of columns. But really, if we're just displaying the body of the post, I don't need all of that, I just need the body, right? So what I can do is define a custom class, DTO, whatever you want to call it, POCO. Run the selection inside of my query, and then the generated SQL is only pulling back the data that I need for the projection, only the data I want, and not the rest of the object. Now, a couple of things here. There is going to be functionally no difference at a scale like this, where it's a single query, 2 fields versus 10. But if you start talking about a lot of users or large objects, or something where you're doing issuing a lot of queries over and over again, this starts to have some real performance gains. Now to your question, this is a great way to not track anything, because Entity Framework doesn't know what that class up there is. It doesn't know that it should be mapped to a table. It doesn't know what the columns are. It just knows it as a class that I'm projecting the results of my query into. So that isn't going to be tracked. Now, this can be good, right? Saves you overhead, saves you memory, but just be aware that that data, as soon as it projects it in there, it forgets about it completely. All right. Okay, async. Sorry, question.
Why is it top 2, not top 1?
Yeah. So the reason it is top 2 and not top 1 is, so you'll notice I've used single or default. And so for both single and first, the SQL that's generated will use the top 2. For first, it's because it needs to grab just one of them. And for single, it's because it needs to throw an exception if it got 2 results. Because by using single, you're saying, I expect there to be one and only one of these, right? And Entity Framework is, in its infinite wisdom, says, well, I want to be able to throw an exception if you got more than one. Likewise, if I just use single instead of single or default, it would throw an exception if I got 0 of them. But it would still ask for top 2. So yeah, good catch. All right, asynchronous. Everybody uses async in their code, right? Yeah, no, maybe. Right, so a couple of years ago I went to a talk by name's gonna escape me now. Anyway, gentleman who said that having async and await everywhere in our code was actually a code smell, and that you wanted to push that like either up or down as far as you could. Anyway, all else being equal, the top one's gonna be faster than the second one. Now, again, this is a question of scale. If your app has 10 users and a 10 gigabyte database, the difference is going to be within the margin of error. It might appear faster, and then the second one might appear faster, and then when you start getting into large workloads, millions of users, terabytes of data, the top one is going to perform better under load. Microsoft has invested a lot in the runtime being able to handle multiple threads and asynchronous execution, and so just use async. However you want to like abstract that away so you don't have like await all over your code is fine, but I would suggest doing it. Also, just to note, the asynchronous enumerable, async enumerable syntax is really tragic in my opinion. Hopefully that gets fixed up soon. Right. SQL Server Indexing. So this is kind of specific to SQL Server. Anybody using Postgres out here? 1. Okay. 2. Yeah, a couple. The similar issues with Postgres. So indexes are really, really good. They help return the data faster, right? Right, makes sense. If you have a book, rather than flipping through the entire book, you can go to the index in the back and go, I want to get Entity Framework Core, and go right to the page. There's a downside with databases though, because it's going to make our inserts, updates, and deletes slower. Obviously, you have to update the index. So that's generally fine, just means we don't want to have too many indexes. Hopefully you have a DBA in your shop that can help you with this. So where we start to run into trouble though is string indexes, so that would be varchar and varchar, string type in C#. They only get used in SQL Server when it's an equality operation or when we're saying starts with. So they're like a trailing wildcard, so like DA %, right? If you start it with a wildcard, it's like, so you say like ends with, right? The index will not be used. On a large table, that could be bad. So just kind of be aware of that. And then the other place where indexes generally don't get used is when you're doing an operation on the column. So, for example, we have our Stack Overflow database. Each post has an answer count on it. Now, why this isn't just calculated from the number of answers associated, but makes sense to somebody, and these guys generally know what they're doing. But if I want to get like answer count divided by 2 for some reason, I should really make sure I don't do that in my query, because that will also defeat indexes, performing some sort of function on the data. If you have a DBA team, talk to them. They want to help, I promise. They only seem grumpy. Yeah, they're probably grumpy. They'll get less grumpy if you ask them for help. All right, yeah, my favorite topic, database design. Unfortunately, you only get one shot to do this right. Who all has the ultimate pleasure and like, we'll call it the best of all worlds of working on a brand new app, brand new database every time you start a new project? Got one. Okay, so the rest of us are stuck with databases that were designed, we'll call it charitably, 10 years ago. But in reality, it might be 20, 30. Working with a client right now that they have not one, but 3 working AS400s with attached iSeries DB2 databases. Yeah. Some really curious decisions in there. Not to mention a whole lot of table names that are like 10 characters. CUSINFAU. Yeah. All right. So, general guidance. Yeah. Okay, so the obvious one is do it right the first time. You only get to design your database right once. Once you've made that decision and there's data in it, it's not impossible, but much harder to change. So we want to make sure we do it right the first time. This means, for one, thinking about how to do this relationally. If you're working with a relational database, if you're working with Cosmos or something like that, it's a little bit, it's a different way of thinking about database design. Because poor design is going to be poor performance. Nothing that I've talked about in this session, nothing that any how to get better performance out of your database, nothing is going to solve a bad design, short of throwing more hardware at it. And hardware is expensive, even today. Right, so mentioned Cosmos, design for your access patterns. So back in my day, we wanted everything to be this perfect third normal form or BCNF, and you just wrote bunches and bunches of joins and it was fine. And then came along this idea of the NoSQL, not only SQL database, and we started to think about maybe duplication of data is okay. Maybe we can design a little bit more for our access patterns, right? And then everybody sort of started being honest with themselves and realized that we'd been doing this anyway. How many of you store, so if you have a user has an address has a state. How many of you store that state in a related table? Three people. Okay, how many of you actually refer to that related table or just put the 3-letter state code on the address itself? Okay. All right, so there are a couple, right? And there is nothing wrong with that. It's perfectly proper relational design. You're also making the database engine work harder. Yeah. So it's a choice, right? We can design in a way that makes more sense. We might not, for reasons, but we can. All right. Avoid table per type, right? So DB context scaffold, or sorry, EF context scaffold gets us a table per type, or a type per table, for, depending on which way we're going. You're kind of ignoring the reason for an ORM, which is to handle the fact that your database and your object model ought to look different. Is a much larger topic, but you don't have to do one-to-one, and probably shouldn't. So like if you have a lookup table, you can do an enum. Using your database as tools. So that's things like views, computed columns, the like. This can help reduce processing, help things be more performant, help smooth around some of the rougher edges in a framework core. This is one of those things that's gotten much, much better. You know how it used to be like if you tried to push in a function in an old school entity framework, it'd just go like, I don't know how to turn that into SQL. It's getting much better at that, but still want to be careful. And then, yeah, code first tools. I'll talk a little bit more about this in a bit. If you have a large project, code first is probably not your friend. But I'll talk a little bit more about that. Okay. Right, so the first thing I want to talk about here is if you're using a lot of includes. And so this can take the form of we just need a whole bunch of related data to do processing with, or the first place that I used this, I was building a system where we had to search across a bunch of insurance policies. And because we were forced into this very nice relational schema in the database, there were 16 tables involved. And so rather than do that every time, we just wrote ourselves a view and said, okay, well, we'll just search on the view. And we could index the view, and it was very nice. Right, so post with post type. So this is a great example right out of Stack Overflow. Each post has a post type. And you probably want to return the text post type, right? So we can define a view and define a custom object, and in our model, just call it, this is our view. And then the SQL against this just gets executed like it would against any normal table. You can filter against it. Depending on how you've constructed it, you can insert and delete and update. Which you probably shouldn't. Questions about this? Pretty straightforward. Okay. All right, my second favorite topic from database design is why you shouldn't use code first. Okay, so I'll start this out by saying, I'm not saying don't use it. Code first is really good if you are starting with a small project, if you need to start very quickly, if you don't have access to somebody who's really, really handy with SQL at the top, if you're rapidly evolving your schema, but you haven't hit production with your data yet, all really good at those things. Things that it's not good at, data types. If you define an object in C# with a string, and you create a database table based on that object, what's the type of that string in your database? Yes. Got half and half. Nvarchar max. And people everywhere are cringing. Yeah. So you just have to be careful, right? You have to make sure that you're being deliberate about what you choose. There's nothing wrong with Unicode, right? This is a part of the world where Unicode probably makes sense on a fairly frequent basis. Where I live, it doesn't. Most people speak American. Right. Indexes, again, so your primary key is going to get an index in SQL Server because that's what it does, but you're not going to get any other indexes, and you have to make sure you define those yourself if you're using code first. And then the last two I should probably just combine on this slide. Basically, if you're using anything other than a table, you have to write it yourself, which can be fine, but if you're using code first because you don't have anybody handy with SQL, or because you're trying to get going fast, or something like that, then that can kind of run you into a problem. So if you need a stored procedure for something, you need a function for something, table partitioning, user-defined types, you have to write it yourself. Other than that, use code first. Or don't. All right. So there are some things that Entity Framework Core and, let's be honest, most ORMs that generate their own SQL are really bad at. Lots of joins. Again, EF Core has gotten much, much better than old school Entity Framework. But if you have a lot of joins, the generated SQL, at the very least, starts to look really ugly, even if it still performs okay. ETL, yeah, so I said that I had a fun story. So you shouldn't use Entity Framework to do ETL work. In fact, I would argue that you shouldn't be using C# at all. So how many people in here like building Legos? Really? Ah. All right, well anyway, Rebrickable.com provides a data set of all of the sets, parts, minifigures, etc. In individual CSV files. And I got tired of using Stack Overflow for my let me play around with things database, and I was like, Legos. I like Legos. And I was like, oh, individual CSVs. Well, this is kind of a pain. I need to get these into a relational database. I bet I can do this pretty quickly with a little .NET console app, any framework. Yeah, it'll be fine. Wrote some generic statements so I didn't have to copy and paste code everywhere. Set it to run. First 6 files, which were all 1,000 lines long. Great, fine, easy, fast. The 1,000,000-line file never finished. It kept timing out. Because I'd be like, oh, it's running, I'll go get a coffee. And I'd come back upstairs, my computer had gone to sleep, the connection with the database had broken, and yeah. So don't do ETL with Entity Framework. It's just not worth it. I can talk about how I solved that problem. Well, you can go see it in my GitHub. Yeah. Anyway, yeah, ETL, bad. Lastly, parameter issues. If you've run into this, you know it. So the parameter issue would be, for example, SQL Server tries to decide what type your parameter is if you haven't specified it. Sometimes it guesses wrong. And if it guesses wrong, guess what? It's not going to use an index. Right. So sometimes you have to write some specific SQL to fix the problem. You'll know that one if you run into it. And lastly, the thing that Entity Framework Core, although the fine folks at Microsoft have been doing a great job addressing this over the years, it's never going to give you the best performance. If performance is that important, you are going to be better off using either writing it yourself or using Dapper or something like that. Basically, if you need the best performance, you should write it yourself. You lose performance with the convenience of Entity Framework Core. Yeah, so its primary goal is reliable execution, not necessarily fast. SQL it generates isn't necessarily going to be the most performant. I did put a note that you really need to be careful with Cosmos because of the consumption-based pricing model. And then, the overhead associated with change tracking. So most of the time it's a benefit for us. Like we're willing to give up the performance for the convenience, but if you need the performance, you have to give up the convenience. All right. So, some guiding words. Understand how EF Core works and doesn't work. Measure your performance. So there are performance counters available beyond what we've seen here with just this is how long it took to execute the query. And if you've done 1 and 2, then number 3 has solved itself, which is that you have a plan to fix it when it goes bump, which it will, because it always does. Questions? All right, if there are no, okay, one question.
Sorry.
Yeah.
As someone who is code first,
Yeah.
up and running, and now reaching scale, are there any good resources for figuring out, like all the advanced features, for example? No idea, got no idea.
Sure.
Any good resources for like taking that next step? How do we look at scale? Or what do we do with the efforts for that point?
Yeah, so there's a couple of things. The first would be a question of, like, have you had to rebaseline yet?
Sorry, have I
Had to rebaseline with your migrations yet?
rebaseline?
No. Okay. Okay. So you're not so far down that it's started to become like a true management pain.
Not yet. No.
Okay. So obviously the Microsoft docs are really good. I assume you're going against SQL Server. Okay. So Microsoft docs are really good. If you're looking to educate yourself on, like, more specifically with T-SQL and some of the advanced features there, SQL Server Central has a Stairways series, both for basic and advanced, that kind of show like how you can solve certain problems just using T-SQL. It can be more performant than what you're getting. And then the next step would be lifting your database model out of your code and into something like Flyway or Liquibase. Flyway or Liquibase, probably. Yeah.
Is there a way to disable default error logging that comes out of the Partitioning framework? So things like unique index.
Yes, but not through an Entity framework. So you have to do that at your logger setup. Yeah. If you're in .NET Core. Yeah.
Is there a way you can disable the equal loading? Like EF Core 6 tries to be even more helpful and tries to predict what you actually want to build.
What version of EF are you on?
EF Core 6, like if you include something previously in the instance, next time you load it, it goes, I'm going to include this for you because I've already loaded the entities. So it tries to be helpful. Is there a way to stop it from doing that?
Yeah, turn on no tracking. Yeah. So that's one where, so the question, I gave a very glib answer, I apologize. So the question was, if I have included something previously, then the next time I go to get the parent entity framework helpfully includes it again. And this is kind of what we're talking about, convenience, right? It's assuming that it knows what you need. And sometimes it's going to be helpful. And so in that case, like, if you do no tracking, then that will solve that problem. The other, yeah, that's pretty much it. I'm gonna have to play around with that one a little bit. I've not seen that behavior myself, so I'll have to play around with that. In the back.
It's been, probably 5-7 years since I played around with it. I haven't done anything with EF Core, just EF. And back then I was struggling with performance issues as related to navigation properties. Has that improved in the last 5 to 7 years?
Yeah, so question was struggling with performance with navigation properties in Entity Framework. We'll call it OG Entity Framework. Has it improved? So yes, and sort of. So Microsoft has done a couple of things there. One, the SQL that gets generated is far less bad looking and bad performance than it was back then. But then the other change that was made for EF Core 5 and 6, or well, it was made in 5 and it's been carried through in 6, is that you no longer have either eager loading or lazy loading available in the core package. Those are separate packages entirely. And so the default behavior, in fact, the only behavior you have unless you pull in one of those proxy packages, is the .include syntax. And so you can be very explicit about what you're loading navigation-wise, and it won't, although my gentleman here, I'm gonna say won't, but I have to do some investigation. It won't load anything that you haven't specified.
So I've been experimenting with performance a lot and talked about how to maximize performance. And I got stuck at trying to maximize it by doing raw queries and DB commands and manual mapping. And I still wasn't able to get it running as fast as on SQL Server Management. Would going into doing views, for instance, speed it up?
So the question was, this gentleman's been doing some experiments with performance, both like with manual mapping and doing things, manual execution, and hasn't been able to match the performance that he sees through Management Studio. So it's kind of apples to oranges. In a way, because Management Studio is really just, like it's tuned very finely, and we're not, it's not doing any object creation under the surface, right? So you're not incurring, like no matter what, if you're in C# and you're mapping the results of a query into an object, you are going to incur overhead with creating objects, right? And in fact, you have some like, you have your DB reader, you have all these things that you're creating as part of the execution, and Management Studio goes about it a different way. And so you're probably not going to get, I'd say you're probably not going to be able to match the performance that you get through Management Studio, but you also probably don't want to.
Maybe a better question would we want to do default SQL to make we need maximum performance, or do we create views?
So a little bit, it depends on your use case. My suggestion is that if performance is the most important thing, I would encapsulate the SQL in a stored procedure. Because for a couple of reasons. One, you're gonna be able to guarantee how that SQL looks. And you're going to save a bit on statement preparation after the first time it executes. If you put it in a view, every time you query the view, more or less, SQL Server treats it as a new query, whereas every time you hit the stored procedure, it's the same query. And if you parameterize it, etc. Obviously, there's a solid it depends there, but in general.
Just a question about migrations using non-code first. Is there any tools or resources you recommend for going down that? Because obviously migrations are going to be needed at some point.
Sure. Yeah. So I really like Flyway. So we have a product that we build internally that we sell to power companies to help manage people getting solar panels on their roofs. And it started out using code first, and about two re-baselinings a year later, we're finally moving it into Flyway. And so Flyway, liquid base kind of work the same way. So I would suggest one of those. Yeah. We are out of time. I'm happy to take any more questions up here in the front. If you think I did a great job, a green. If you think I did an okay job, a green. All right, thank you all very much. I'm happy to answer any more questions up here.